evening. Everybody find your chairs. We have a much bigger crowd than people who signed up, so I apologize for a little bit of shortness of chair. Thank you for coming, even on a rainy, not snowy night. We can thank somebody for that. Welcome. This is another edition of the Centerbrook Architects Lecture Series presented by the Essex Library Association, a member-owned library. I will remind you all, just in case you haven't sent in your notice of membership, with a check. We are very happy tonight to be having Bill Grover come back and speak with us. You all were here in November when he came and spoke with Nobel laureate Jim Watson. It was a great evening, and Bill has agreed, after we nearly broke his arm, twisting it, to come back and talk to us about a very special subject of his, color. And I want to remind you, a little housekeeping here, on April 22nd we have Dr. Chuck Benson coming back to speak to us about Bernini, the genius of Italian Baroque, and that'll be a beautiful talk again. And we have on May 20th, Raphael Pelli, who's coming to speak about sustainability in some enormous glass and steel buildings around the world, if you can believe it. And on June 3rd, we have David Greenbaum from the Smith Group, who's coming to talk to us again, not again, it'll be his first time, about the Normandy Visitor Center at the American Cemetery in Normandy, France, which will coincide with our VE celebration weekend at the library, which is part of our Veterans Day program that we always carry off on in November. So be sure to write those down in your calendar and be here. One more thing, because you always have to learn something about the library while you're here. Did anybody pick up one of the new release alerts from the Essex Library sheets in the back? Anybody know what the new release alerts are? No. All right, fine. And I think we are the only Lion Library out of the 23 Lion Libraries right now that allow you to do this. This is a real service that you could be making. You could really game the system with this. And this is why we do it. Books that are going to come out, James Patterson's 15th book of the year will be out next month. And it is going to have heavy holds. So if you don't want to be the 20th person in line waiting for that book, we let you know way in advance before the book is released. You can put a hold on that book before anybody else. That's what the new release alerts are. And every month, on the first of the month when we send out the newsletter, there are 5 symbolic new release alerts in our newsletter. You can click on those immediately, or you can always go to our website, and the complete list of new release alerts is on the website. Now that's not to say that we don't order more than 20 books in a month. We order a lot more, but these are the 20 that we figure are going to be the heavy holds. So get in there every month. You can see them, come in and ask us, call us, we'll put the holds on for you so you don't have to wait and wait and wait for a book. Done. I'd like to introduce my husband, Jim Childress, partner of Centerbrook Architects, who is going to introduce partner emeritus, Bill Grover. So here's Jim.
I'm guessing most of you know Bill, or you know of Bill, and probably in good ways. So there's probably not much introduction, but I should say a few kind things for him. And certainly known him for years. And it occurs to me that, they always say about a Renaissance man is somebody who knows a little about a lot, or really nothing about anything important. And I think Bill knows a lot about a lot. And I started thinking about it. He's obviously a really great architect. He's a very good writer, if you don't know it. Didn't win at the spelling bee. That's why you're not up there tonight, I know. But still close, was competitive. He's a great musician. Plays a very good, really cool trumpet. Is a sailor. And I'm leaving some things. Oh, he's a great tinkerer. He has a MG, I don't know the model of it. It's a beautiful car that he redid that you'll only see on nice summer days when it's not raining. And I think with Paul Rousseau, right, you're working on a solar-powered boat in his basement. He also, on top of all of that stuff, is, I think, arguably a world-class watercolorist and really knows color. I think he's thought about it his whole life. And he's going to talk about this tonight. He refused to tell us exactly about what. I got the sense we're not going to learn what color to paint our house tonight, but maybe. He might help me with my clothing and what tie to wear on my jackets, but I think he's really researched this and has some great thoughts. Look forward to it. Bill, you want?
Thank you. Can everybody hear all right? If I start to mutter, raise your hand. I'm not sure why Jim and Ann asked me to do this, because I am not by any means a color expert. If I'm a Renaissance man, it means that I haven't studied anything really very thoroughly. But I'm interested in a lot of things, and so I get excited and study. I started studying about color about 4 weeks ago when they asked me to do this. But I do remember that I did go to art school, and they did teach me a lot about color back then. And color has been important to me in architecture. So what I'm going to do tonight is to tell you a few technical things about color, and then a few stories about how color developed and where colors came from, and then some architectural uses for color that I have put for use in my career. All right, to start out with some of the technical things. The electromagnetic spectrum goes all the way from AM radio on the right, up to shortwave radio, television, FM radio, radar, infrared rays, and right between infrared and ultraviolet, X-rays go on beyond that, gamma rays. There's a part of the electromagnetic spectrum that is visible light. That's the part that human beings can see. There are other animals and insects that can see other parts of this. They can see ultraviolet and infrared for whatever reason, I'm not sure. Those light rays go into the eyeball, and they land on the retina in the back. And in the retina are thousands of little rods and cones, which are receptors that can detect light, and they can detect the color of light. And then those go on little fibers all the way through the optic nerve to some part of the human brain. The human brain is pretty amazing that it can do all this. It can look at all these things and see what colors they are, and they can remember colors too. Here's a color wheel of kinds. The basic colors that we are concerned about are red, blue, and green. Red on the bottom. Wait a minute, I've got a little laser thing here. I don't know how to use the little laser. I have a technician. Oh. Okay. All right. Okay, in this diagram, this is black in the middle. This is white out here. There are different characteristics of color that we use throughout. One is hue, and the hue of a color is whether it's red, green, blue, yellow. That's how you define hue. Value is the lightness or darkness of the color. So this is black, and it goes lighter out there. Chroma is the intensity of the color. So these little colors out here are not too intense, and the color in here is not too intense, but the chroma, this is probably the most intense area of the color. Tint is really not another definition of color, but when you want to make a lighter tint in pigment, you add white. When you want to make a darker shade, you add black. So those are the important things to remember. Now you can forget them all. And if you go to the theater and they show a spotlight on the stage, they show a green spotlight, a blue spotlight, and a red spotlight overlapping like that, you will notice that the color in the where the blue and the red overlap, you get purple or cyan, purple, which is violet, and you overlap the red and the green, you see yellow, overlap the green and the blue, and you see what we call cyan. And right in the middle, where they all overlap, the light will be white. Now, this is different from pigments. Pigments are ground up particles that are of color, that are mixed with something like linseed oil or water. And the pigments, which are used in the color printing process, are called cyan, which is the blue, yellow, magenta, and one more, which is K. Why they call it K, I don't know, but it's black. But if you mix pigments together, you mix all those three pigments together, you'll get theoretically black. This is what the color printing process really looks like up close. It looks like, it should look like an eyeball to you from a distance. But you'll see all the little dots are made up of cyan, magenta, yellow, and black. So if you take a really strong magnifying glass and you look at a picture in a magazine, this is what you'll see. These are the pigments. Pigments are ground up particles of everything from rocks to flowers, plants, and things. Along the bottom row here, you'll see a blue pigment. This is on a surface, a blue pigment. When you look at a pigment and it looks like it's blue, it's because it's absorbing green, it's absorbing red, but it's reflecting blue. That's a fairly simplistic. Back in about 170,000 years ago, in the caves in Lascaux, the guys were sitting around because there was no TV, there was no Netflix, there was no other way to entertain yourself except to sit around the fire. They take a piece of charcoal and try to tell other people what they had seen or what they had captured. And they make a little charcoal outline. But all animals were not charcoal colored. So they wanted to differentiate one animal from another. And in this picture you'll see that this is a brown animal with a dark brown, almost black head. This is a white animal. Looks almost like a cow or a bullock or something. And then there were other animals down here that were brown. And in this way they were able to show other people what was going on and maybe teach people that this is the one you want, but don't mess around with this one up here. And what they used for color on those things was dirt. They would look around and they'd see that color dug up in the ground over there looks something like the color of that animal. And they take this dirt and mix it with water or saliva or animal blood or something and paint it on those these pictures. So that's where most of the first colors that were used by artists any place really came from. And then when they found out that it was good to get yourself decorated up, you could decorate yourself in ways with colors that would scare off your enemies. So they try to make the most dramatic looking headdress. These are the people in Guinea. And it looks kind of like a skull with teeth sticking out. And from a distance it looks good. Here it looks frightening. Part of this was to get your whole army decorated up in kind of the same way, so that if you were fighting with another army, you would know which were your guys and which were their guys. An American Indian looks pretty fierce. This would scare you off if you saw him charging I don't know why he has blue eyes, but that's pretty scary. Color is also exciting to people because they could use it in religious ceremonies. This is a Hindu religious ceremony where they, at the time of a holiday called Holi, which just occurred a few weeks ago. And my daughter is in India, and she said that what they do is your neighbors come around and they have some colored powder, and as a sign of friendship, they put a little colored powder on your face. And so all the neighbors start to do that, and they go to everybody else's, and eventually it works into something like this, which is, this is kind of the other end of the celebration. But everybody's having a good time. This is not something where people are mad at each other. They're happily decorating each other with colored powder, which is, I understand, either flour or talc that's been colored with some kind of pigment. Mother Nature does it best, however. And whenever human beings have seen these colors, they wanted to take these colors and apply them to their paint and their artwork, and to find out how to do it. The Dutch plant tulips, and this is you can see the canals through this, but this is annual planting of tulips. Much more mechanized now than it was originally, but colored tulips were a big economic boon to the Dutch. Here's another interesting one. When the Spanish invaded Central to South America after Columbus in 1492, around 1500, Spanish got into South America, and they were attempting to find gold and silver, which they found some of, and they exported the gold and silver back. The third most big export from South America was a color. It's crimson color that's in the background of this. This is crimson and indigo and some other colors of white. This is a cactus. This particular cactus has an insect that lives on it. The white stuff that you see on this picture is covering up the insects. They get in there and they suck the juice out of the cactus. And in doing so, they excrete a bright orange color. Here's the bug. A lot larger in this picture than it is in real life. And here they are taking the bug, and they pick off, let's say they want to make a pound of this color. They pick off 70,000 little bugs, boil them in water to get that white stuff off of them. Then they roll them out and squish it, and pretty soon the dye comes. This dye was called cochineal, after the name of the bug. Cochineal dye is still used in the cosmetic industry and in colored drinks, soft drinks. It's less toxic than the aniline dyes that are used, that were made later. But at one point, this was the third largest export from South America and Central America. And it was a Spanish monopoly that lasted for 150 years. And the Spanish would sell this stuff to Europeans who really liked this color. And the colors that were most valuable were the ones that were the hardest to get, obviously. So popes wanted this color, but they had to buy it from the Spaniards. And the British eventually got tired of buying these colors from the Spaniards. These colors of British uniforms, there's a story going around that the reason that British uniforms were red, for the redcoats, was to hide the fact that they had been shot or were bleeding. But the real reason was, just like those natives, they wanted to be sure when they were in the field that they were shooting at the right guys. And the other guys were not wearing red, and the British were wearing this bright red, and the British could afford this bright red by buying it from the Spaniards. But around 1750, Mr. Buell will tell me if I got the dates right or not. 1760s to 17, I think about the 1760s, a French ecologist went to steal some of those cactuses from Mexico and took them to Haiti, and then they started raising them in Haiti and other places. And I think about the end of the time of cochineal big run, they had shipped 250 tons of cochineal pigments to Europe from the Canary Islands. Remember that it takes 70,000 beetles to make 1 pound of this dye. The stuff was very expensive. They still use this color today. Another interesting one. This is Vermeer, the milkmaid. And Vermeer really liked that yellow color. The yellow color was not easily available for any place. Right now, at this stage in history, the only time you could get colors was from digging it up out of the ground or from finding a place in South America. And so it was very expensive. So he found out about Indian yellow. And Indian yellow was very expensive. It was made by Indians in India by feeding mango leaves to cows. They would feed these poor cows mango leaves, which didn't really agree with the cows very much. It wasn't very nutritional. But they would then collect the urine from these cows and boil it down and make Indian yellow, which they could then sell to European painters. That's great. Blue was another color. Jan van Eyck used to charge people who wanted their portraits done. This is a Gainsborough, but Van Eyck charged his clients extra if they wanted blue in the painting. Because the only place they could get real ultramarine blue was from lapis lazuli in northeast Afghanistan in the mountains. By climbing up the sides of cliffs and getting small portions of this stuff out of there and bringing it back and selling it to the artists. So this was a very popular color, and it was also a color that was regarded as something that a really rich person would wear. So I'm presuming that Gainsborough probably got some of his colors there too. Another color that was very popular was even more difficult to get, starting about, I think the records show someplace around 1300 BC along the Mediterranean. People would pick up these shells, a particular Murex snail. This is about 5 inches long in real size. And some of the membrane in the Murex snail had a color which they called Turanian purple. And a very small quantity of it. It took a lot of these shells to make a significant amount of purple, so that a robe like this would be very valuable, and it would be only worn by a person of either high religious or high power person, power color. Then, this is an important date, 1856 in March. Henry Perkin discovered the first aniline dye. And the story is much more interesting because Henry Perkins was only 18 years old when he discovered it. He was working for a chemist, and they were trying to figure out how to make coal tar into quinine to help cure malaria. And coal tar has many different chemicals in it, but so his boss, whose name I can't remember, said, look, I'm going off on about a 6-month sabbatical, and while I'm gone, I want you to try to figure out how to get quinine out of coal tar. So the kid set up his own laboratory in his home, and he was working on it, and many failures, and each time he had a failure, it would leave a black gunk in the bottom of the jar, and he'd have to clean it out. So one day he had made something and tried to clean out the jar with alcohol, and it turned out that he made a purple dye. Here's a sample, the actual sample of the first purple dye that he made. William Henry Perkins, I think was his name. So at age 18, he and his brother, with the money from his parents, set up a dye works in England and started manufacturing this stuff. And this was the beginning of aniline dyes, which meant that you didn't have to get 12,000 snails and pound them up and heat them, boil them, and mix them with salt water and everything. You could just get this chemically from aniline dye. And aniline was a material that was a byproduct of making coal gas. And coal gas was what people used to illuminate their houses in England at that time, and even in the United States. Iverton had gas, or they had a gas plant. And you took coal, heated up the coal to a certain temperature until it was glowing, and then they put steam on it. And the gas that arose from that was essentially carbon monoxide. But carbon monoxide was flammable. So then they put pipes in the ground and they bring it around to the lamps. The lamp lighter would go around and light up the lamps. And the residue from this aniline was like tar. It was basically what they call coal tar, and it was used to make macadam and other things. But Perkin, at age 18, figured out how to make a dye, and he started this little factory. And by the time he was in his 20s, he had made a fortune from this, sold it out, and retired. An extremely wealthy man. So remember that. When you're fooling around with your chemistry, you come up with something. Serendipity always helps to pay off. Nowadays, using coal tar aniline dye, you can make almost any color you want to. They found out that you can make many, many other colors. This is Pantone, which is now one of the color standards, probably the preeminent standard of colors. And any company that makes any product that they want to be a certain color specify a particular Pantone color, and it can be matched to the standards. So we'll drift into architecture from here. One of the first questions, why are barns red? And there are a couple of reasons. One is that Scandinavia, they found that digging up iron ore and copper and cooking it up in some way would make a liquid that you could paint on wood that would preserve it. And then, shortly after that, they figured out that if you took lead and you heated it up in just the right way with sulfuric acid, you could get red lead. And red lead is still used today because it's particularly good protectant against rust, but it was also a protectant against the ravages of weather and the sunlight. So that's why barns were mostly red. And even after they were able to come up with other colors, it had become such a tradition that everybody painted their barns red anyway. This is an old building that's probably painted with red lead. The next question is, why are houses painted white? And there are a couple of reasons. Some of it is tradition, and we'll talk about that in a minute, but it's also white lead, which was another substance of lead, and you paint that on there, and white lead mixed with linseed oil and milk and other things would make a really durable white coating for a house. It would reflect the sunlight, and which was one of the major things that damaged wood on buildings. So white lead was used. Neither white lead or red lead are now allowed to be used today, except in special circumstances. Red lead can be used for waterproofing underwater parts of boats. Another reason for whiteness in buildings was the 1893 Columbian Exposition in Chicago. It was mostly designed by Daniel Burnham. These buildings were classical in design, and Burnham was a lover of classical buildings. They made almost all the buildings they were in white. And the material was called staff, which was like a fibrous material that they nailed on the outside of the buildings and then put plaster and calcimine on it, and didn't really need to paint it. They were in a big hurry because you may remember that they were celebrating Columbus's 1492 arrival in the New World, and this didn't really get underway until 1893 because it took so long to build all this stuff. But this kind of became the standard for what you might build public buildings. And also the White House, which was there before that, was not called the White House at that point, but it's been white, and people tend to build their houses to look like important buildings. Burnham was inspired by the Parthenon, by the Parthenon, but the Parthenon was only white because it sat in the sun and the rain and Greece for so many years that the colors washed off. Originally, these theoretically were the colors, but they didn't have really permanent paints, and so the paints washed off. When things went downhill, they didn't bother to repaint them. People always like to paint their houses in some way. In Africa, people paint their houses with some kind of a symbolism, decoration on them that has something to do with how many children they have, where their uncle lives, so that people going by their house can get a little bit of a background on their family history. This is in Ireland, I think, and at the time when they were building row houses, people wanted to have their house stand out from everybody else's. So they started painting them different colors when the colors became available. This is the island of Burano in Venice. Burano is a lace-making island off the coast of Venice. And these people, I think, have realized that it's also a tourist attraction if you paint all your houses in rainbow colors. And also you can tell whose is whose. Go to the third blue house down from the bridge. Also, some of the colors in the dark parts of the city are blue because it gives you kind of a cool feeling when you're walking in the shade. This, I believe, is Iceland, or it's one of the Scandinavian countries. And it's not clear why they painted all their houses different colors, but probably to relieve the boredom of everything dark and gray. When Queen Victoria came in, there was a big excitement about colors, and she was a proponent of colorful things. And the new paints, the aniline dyes, came along and allowed people to paint houses color. And several authors wrote books on how to paint your house a color. And here's some examples of colorful Victorian houses. Kept the painters in business. But I think the main idea was that it gave you an opportunity to make a house that stood out from everybody else. And that was at a time when people who were rich wanted their houses to look rich and to be prominent in the landscape. This is in the Caribbean, and that's probably to attract tourists. My experience with color has been mostly on single-family houses. This is a house in Essex that I did for a man whose wife had died. They lived in a big white house, next to a cemetery. And the house was too big, his children had moved out, and he wanted to build a small house just for himself. And so this is built on a high street. And the colors were chosen to fit into the trees around and to not look bright and white like the old house. So a lot of the colors come from the owners of the houses who want their houses to be a certain color. And a lot of them come from me trying to convince them to do something else. And this is one of those cases. This house was built for a couple who bought a huge property up in the Berkshires. And one of the areas that they liked the most to build their house on was the top of this big meadow, this hill. And I pointed out to them that if they didn't want to look like newcomer tourists, she wanted the house to be sort of gray with white trim, you know, like you'd find in New England, Nantucket. And you can drive toward this house from the other direction, and you can see it from about 2 miles away. And if it had been built in Nantucket style, it would have looked like a New Yorker showing off. And I said, you know, you have to decide if you want to look like a New Yorker showing off, or if you want it to look like it's a farm. So I finally convinced them with a few watercolors that it should be looking like a barn with a silo and another blue building for a garage. The silo, in this case, is actually a wine cellar in the basement. This is multiple story. Wine cellar in the basement, a laundry room at the main floor, a study that matches up with their bedroom at the next floor up, a meditation room at the next floor up, and then an upstairs deck on top of the silo. But from a distance, it looks like a silo. Jose Luis Barragan was a South American architect whose work I really liked. And he used a lot of reflecting pools. This was a horse stable, actually. And bright colors of stucco. And I really liked the idea of bright colors of stucco with smooth surfaces. It wasn't made out of boards. And great colors. So I started using, on a number of houses, different colors to break up the mass of the property. This was a house for some people in Killingworth. The white part of the house had been in the family for many, many years, and they lived in that while we were renovating it. But they wanted to add on a master bedroom, they wanted to add on a big living room, and they wanted to add a porte cochere. So I started explaining to them that if they wanted it to look like a huge compound of rich people right on the main road, that they should paint it all white. But if they wanted it to look a little more like a farm that had been added onto over the years, we could do it in a multiple of colors. So this is the backside that you don't see from the street, but it's the entrance to the house. Porte cochere, big living room. Master bedroom is red over there. And there's a dining room that's white, part of the main house. And I think that was successful. This is another instance. This is a house that you can actually see from the Connecticut River near Essex. And it was designed for Walter Rowe, who was a sea captain in the Navy. At the time, Walter was about 80 years old, and his wife, Gay, was in her 60s. And Gay wanted a house that was sort of bright and colorful, like along the main street, it would be yellow with white trim. Walter didn't want anybody to see his house from the river. He wanted to disappear because he didn't like the look of the Connecticut River when you looked up and saw all the fancy new houses along the river. So we matched the color of tree trunks. Try to make the riverside the color of tree trunks. But the other side of the house is a white and yellow. This is another house in Essex that was added on to, partly to disguise the fact that the original house, which was in good condition, was not very pretty. And the owners wanted it to be prettier, and we cleaned it up a little bit with some nice landscaping. And built a red garage over here, and a red pool house. Oops. Yeah. That's the red garage. And back up a little. So the idea here was to make it seem like a compound of smaller buildings, outbuildings, and a house, rather than one giant house. This is a house on Long Island that has a story to tell, which is that Jim Watson, who was speaking with me here a few weeks ago, and his wife were building a new house there, which would be the president's house of the laboratory. And the president's wife wanted it to be a particular color. But every time we went to the store and got samples of paint, we brought them out and painted them on boards and things, it was the wrong color. Which brings up the story. If you're going to paint your house, and you go to the hardware store and you pick out some color from the color wheel, make sure that you get a quart of it and paint it on a 4x8 sheet of plywood and put it up where your house is going to go, and look at that before you buy all the paint and have it all done. The painting a house is very expensive, and if you get it up there and it looks really ugly, you don't want to have to spend the money to repaint it. Well, we did probably 8 or 10 panels of colors to get this one. And this was supposed to be a match of a color of a house nearby across the harbor. And we did that one. She didn't like that color, so we kept modifying it. Eventually we got it. The previous house that we had renovated for them, we did the interior in many colors, which she liked. But we tried out, I would say, 30 different colors, at least, and we'd get a gallon and paint some on a wall and say, no, that's not it. You get another gallon. So they saved all the gallons that were not used up, mixed them all together to paint the attic. And the result was olive green. That's what you get when you mix all the colors together. But this was to be, like a little beautiful house overlooking Long Island Sound. This is Cold Spring Harbor. We're now getting to the later part of my career. The Cold Spring Harbor Laboratory. This is the lab, which some of you may know, on the north shore of Long Island, just west of Cold Spring Harbor Village itself. This has been a research laboratory for more than 100 years, biological research laboratory. Jim Watson came to it as a director in the early 1970s, and it was pretty run down at that time. And he asked us to come and renovate his house, which we did. And after that, we renovated a number of other buildings, and by this year, 2011, we've probably touched every single building in this picture and more. The building at first got us in the color mode of what is it going to look like. This site is visible from across the harbor, and they wanted to expand, but they didn't want it to look as if they were building a giant research laboratory, because this is in Laurel Hollow, which is part of Oyster Bay. It is the only non-residential use in that whole town. And it was also a nonprofit, which meant that, if they built more things, that Oyster Bay was not getting, or Laurel Hollow was not getting the taxes from it. But they reached an agreement where they would pay some money in lieu of taxes, and expanding it, more zoning, more master plans. So this master plan shows the, this is the building that I just showed you that was, I think I just showed you. Here's a model of it. Jim Childress and I worked on this building. It is actually two buildings. This is the Dolan Hall, which is, this is Dolan Hall here, which is like dormitory classrooms or dormitory rooms for visiting scientists who come for a 2-week program. This is the administrative part of this neuroscience laboratory, which is essentially a big box. And we didn't want it to look like a big box from a distance. So this is what it looks like from a distance. The white buildings in the foreground draw your attention. Those were here for maybe 100 years. Jones Laboratory, which is one of our first projects there, was built in 1894. But this is a huge building, and it's designed with trees and color sort of fit in the landscape. And that became kind of the mantra for things. They didn't want to show off what a big fancy laboratory they were, but they wanted to get things, build more things. This is a watercolor of a laboratory that was donated by Nancy Marks and her husband, which is a special research laboratory for examining the neurons of animals while they're alive. Small animals like rats primarily. And in order to make, because of its complicated configuration, in order to make it look like it was a farm building with other buildings attached, we did the old red, green, and blue trick. Then we were asked to do a master plan for the whole future of the laboratory, which is, this is a hilltop. This is a very steep, it's probably 180 feet up from this shoreline up to this part of the hill, which is about 18 stories. And part of this project was going to be research laboratories, which were in this general area, and an upper campus, which would become the Watson School of Biological Sciences. And underneath this was going to be parking. Jim Watson hates to see cars, and we all really don't like to see cars all over the place. And so he's ready to raise the money to bury these cars. But the first buildings that were going to be built here were these 6 laboratory buildings. And this is a kind of aerial watercolor of the whole place. Here are the 6 new, this is the building you saw before, which is a neuroscience building. This building here is the, this building here is the one, the blue, red, and green building. And this campus piece was going to go up through a pathway that went all the way up through here to the upper campus. So this is a computer drawing of the 6 buildings. And they are made so that you can have a parking lot on top of the hill that is essentially invisible up here because it's got trees planted around it, and it's on a flat top that's higher than any other surrounding area, so you can't really see the car. A new road that circles around here, and these 6 laboratories to begin with, they had to be built like this for a number of reasons, but the primary reason is that he was unable to raise the money to build all 6 laboratories at one time. And so the idea came up to build maybe 1 or 2 at the first, and then add more later, which is really pretty impractical. But underneath this whole whole courtyard, and underneath all these buildings are the auxiliary services for all these laboratories. It has all the glass wash kitchens, the storage for laboratory equipment, incubators, all kinds of spaces that don't really need light. So I did a watercolor of what I thought these buildings ought to look like in color. And this kind of shocked the Board of Trustees. But I figured I'd give them the watercolor early so they could get used to it more. This was about probably 5 years before it got built. So what we did to pick the colors, and this is what you do when you want to pick the color of your own house, or especially if you're on a building committee, which is trying to decide what color to build a building. We picked out a whole lot of colors from Benjamin Moore, and we painted 4x8 sheets of plywood with these colors, put them up in the woods where the laboratories were going to go, and had the Board of Trustees come and look at it, and the building committee come and look at it. And they each expressed interest in some of the colors and hated other colors and said, why don't you paint it gray with white trims? And we explained all the reasons. But we kept having these meetings with the building committee until we wore them down. Finally explained to them that buildings look different on different sides and different lights. And so on a sunny day, slightly afternoon, these colors look quite a lot different on different sides. For example, this is a blue building. Looks very light blue here, and that's the shady side, the green shady side. So these were the final colors selected by the building committee after we bored them to death by showing them more and more colors. So if you want to get the colors that you want, you have to bore everybody to death until they decide. So this is the final color scheme for the building. Upper picture is a photograph from across the harbor looking at the site. And the lower picture is a computer rendering of what it's going to look like with the new buildings, to show that it looks more like a village and that it doesn't look like a giant industrial building. Take a look at this. This building is probably bigger than some of the Pfizer buildings. There it is in the morning. So this is pretty much my story about colors. And I'm willing to, I don't know how long I'm an hour. Okay. These buildings look even neater from inside the courtyards. Looking at them, I think it's an aerial view of it. So there's a pathway down through the whole complex. And somebody said, well, there's too many stairs in there. But I said, you know, if you're incapacitated, you can get from any level of this building to any other level, indoors by elevator. You don't have to go outdoors. And you don't have to climb a single stair if you don't want to. But climbing stairs is good for you. And since we got this site, there's a road that goes up around the other side. This is the chimney for the boiler plant in the basement of this, and also ventilation for all the laboratories. The top is stainless steel louvers pointing up so you can't see what it is. Nice terrace just outside the coffee shop in the central plaza. Each building has a donor, and the donor gets their name on the building that can be seen from the courtyard. Total project cost of this was about, including everything, probably $150 million. But it's a big laboratory. I hear people getting exercise running up and down the stairs. So that's my story. If you have any questions, I'd be happy to answer them for you. Oh, one more question. How to decide what color to paint your house? Nowadays, almost any color is available, and these people in San Francisco decided to use all of them. Each clapboard is a different color. So that's the end of the talk.